Hello everyone, welcome back to our channel. Now we are going to discuss about motion in a straight line SAQs, short answer questions. This is also very important for Board of Intermediate from both Telangana and AP State. In this chapter, our first short answer question is in the case of non-uniform acceleration. We know that there are four equations of motion: v equals to u plus at, s equals to ut plus half at square, and then v square minus u square equals to 2as. In all these cases, acceleration is uniform. Suppose if the acceleration is non-uniform, what about the equations of motion? That is the question. Look here, it is not that much important, but it's very important for mains also. Look, we know that acceleration is the rate of change of velocity is called the acceleration. And we do the cross multiplication, dv equals to a dt. Both the sides we are taking the integration. So here u is the initial velocity and v is the final velocity. So lower limit is the u and upper limit is the v. Then differentiation integration cancel v minus u. But we can't cancel this one here. This is non-uniform acceleration. When we are sending u is this side, this is the first equation of motion in the case of non-uniform acceleration. So clearly we can observe that integration symbol is there. Generally v equals to u plus at, but in this case integration symbol is there. Then like that we can go for next equation of motion. Look, acceleration is rate of change of velocity, but here we are multiplying and dividing with x, dx by dx. Then it should be a dv by dx, dx by dt. But instead of dx by dt, rate of change of displacement is nothing but velocity. See, if we want to write one more step, we can write it a equals to dv by dx into v. Then this is v dv, I am taking as a LHS, this is the a dx. Then both the sides we are taking the integration. Here this formula is v square by 2. First we apply the upper limit, then lower limit by 2. Don't cancel and anything, compulsory integration because it is the non-uniform acceleration. Finally we are getting v square minus u square. 2 is sending this side. 2 into lower limit is starting position is the x naught and final position is the x a dx. Then one more expression, velocity equals to rate of change of displacement. So v equals to dx by dt. We do the cross multiplication, dx equals to v dt. Then take the integration both the sides. Here integration differentiation cancel. Upper limit minus lower limit equals to integration of v dt, and here also limitations are 0 to t seconds. Our next SAQ is we have to prove that, see, one body is started, initial velocity is the v1 at t equals to 0 seconds, velocity is v1, and after t seconds that velocity is v2. And in that question only they have given, we have to prove that average velocity equals to v average equals to v1 plus v2 by 2. This is the question. Then how to solve this one? We can go through the, if there are many methods, which is the comfortable, we can go through that one. Look, I am taking this. We know that third equation of motion, what is that? V square minus u square equals to 2as. But instead of v, this is final velocity, this is initial velocity. I am writing s equals to v square minus u square equals to 2a. But instead of v, that is the final velocity v2, instead of u, initial velocity v1, and you know acceleration is the change in velocity by time. Change in velocity by time. So we substitute, all these values are here. So s equals to, what you are getting, v2 square minus v1 square divided by 2 into, instead of acceleration, v2 minus v1 by t. Then s equals to, this is like a square minus b square formula, v2 minus v1 into v2 plus v1. Then t is also coming as a numerator. Down you are getting 2 into v2 minus v1. These two are cancelled. Now I am sending t is this side. S by t equals to v1 plus v2 by 2. because a plus b equals to a minus b. We should write it v1 plus v2 by 2. But displacement by time is the average velocity. So v average. If we consider only magnitude, that is called the average speed also. So v1 plus v2 by 2. This is our second SAQ. They have given initial velocity at t equals to 0 seconds v1, and after t seconds velocity becomes to v2. And we have to prove that average speed equals to v1 plus v2 by 2. So we can use with the help of the third equation of motion, and we can solve like this. Third question is, we should remember this question properly. Is there any possibility the velocity and acceleration both are having the other directions? Generally what we are thinking when the body is running, when the body is walking, or we are walking and we should consider the vehicle, we can say acceleration and velocity both are having the same direction. But the question is, can the velocity direction is other than the direction of the acceleration? Is it possible or not? Whenever they will mention that question can means, we can give immediately is it yes or no. Here the answer is third one. For writing S, we can get 1 mark. Then other explanation is what? We should give the example. What is example for that? Suppose this marker is there. When the marker is throwing upwards, then what happens? Marker is going upwards. After reaching some height, nothing but maximum height. At maximum height, what happens? The velocity is equals to 0. But acceleration due to gravity is always acting downwards. Here velocity is acting upwards, but even it is going upwards, what happens? Here the body is going upwards. Velocity is acting upward direction, but the acceleration due to gravity is acting downwards. At maximum height velocity is 0, but even though acceleration due to gravity is acting downwards. Then our fourth question is, when person is jumped from the aeroplane or helicopter from at a height of 3 kilometers. After traveling some distance, when he is at 1 kilometer distance from the earth, he opens that parachute. Describe his motion. Look here. Whenever the person is jumping from the aeroplane, he is going, because of the earth's gravitational force, he is coming faster like that. After traveling some distance, what happens? His weight is balanced by the air resistance. Means upward force is equals to downward force, means resultant force is how much? 0. Whenever resultant force is 0, here after some time acceleration equals to 0. When acceleration is 0 means what do you say? Here velocity is constant. Whenever the velocity is constant, this is called the terminal velocity. Same experiment. See, one jar we are taking water, you drop one body, what happens? After traveling, that is getting the constant velocity. That is called the terminal velocity. Same, when the person is jumped from the aeroplane, first he is moving fast, like that velocity is more. After traveling some distance, what happens? His weight is balanced by the air resistance. That velocity is constant, and we can call that is called the terminal velocity. Then after traveling some distance, he opens his parachute. Then what happens? His air resistance and gravitational force, like that in this case also balanced, but the thing is he is slowly landing on the earth. Velocity with the slowly landing of that one because of the opening of that parachute. This is the description of that person when he jumped from that aeroplane. Our fifth question is, one bird is there. That bird is having one fruit. When the bird is dropped that fruit, what about its path with respect to bird and we are standing on the earth? The fruit is same, but when we are looking with respect to bird, that is having the straight line path, and with respect to the person on the ground, it is having the parabolic path. Look here, this is the bird and it is having one fruit. Whenever it is dropped, what happens? With respect to this one, it is moving horizontally. Whenever it is dropped, it is also coming like what happens, same velocity. With respect to this one, it is the straight line path. But the person standing on this, the fruit is coming like this. So simply we should write it here. With respect to bird, that is having the straight line path. With respect to person, that is called the that is having the parabolic path. Same thing we can observe that in the case of train also. When we throw water bottle through the window, what happens with respect to the person inside the train, that is having the straight line path. We feel that bottle is going exactly down like that. But the person who is on the ground or on the platform, it is having the parabolic path. So only one fruit, there are different paths based on the reference frame. Then our sixth question is, see, don't do this experiment. The person is jumping from one building to the another building. Look here. This is 9 meters building, first one. And second one is how much? This is the second building. Clearly they have mentioned difference of heights is 9 meters. Then distance between these two buildings is 10 meters. The question is, safely he will land on the other building floor or not. Here one formula we are using, that is range equals to u into under root 2h by g. With how much velocity he is jumping from there? 9 meters per second. So instead of u, 9. Under root height difference is how much? 9 meters. 9. After simplification, 9 into under root 1.8. This value is 12.074 meters. See, the difference between how much gap is there between the buildings? 10 meters. But he covered how much distance? 12.074 meters. So you can say safely he is landing on the other building floor that one. So this is, we can use this range formula, u equals to under root 2h by g. Then our next question is, they have taken two stones. Even we do this experiment. One is throwing with some velocity. Another one is dropping. Okay. So which ball will reach the ground first? So try to understand this. This is, we should consider first body, freely falling body. Freely falling body, initial velocity how much? 0. We can take it, this height is h. H equals to half gt square formula. First body means t1. So t1 equals to how much? Under root 2h by g. How much time it will take when the body is dropped, initial velocity is 0. T1 equals to under root 2h by g. Then our next question, next part is, second case is, at the same time, there is no time gap. We are throwing one body. In that case, how to find out the time? Look, same formula we are using. See, whenever it is throwing, initial vertical velocity is 0. We can go through the s equals to u by t plus half g t2 square. Displacement is nothing but height of this one. Vertical velocity is 0. Half into g into t2 square. Then t2 equals to under root 2h by g. Even we are throwing or dropping from certain height, both the stones are reached to the ground simultaneously. Both are taking the same time. Why? When we are throwing, both the bodies are at the same time. That too, height is same. So both are reached to the ground is also at the same time. First case also under root 2h by g, and second case also under root 2h by g. Purely it is depends on the height of the tower. Our next question is, 8th question. Find the relative velocity. Look, when the body is freely falling. For freely falling body, we are taking first case. Look, for freely falling body, initial velocity is how much? 0. After traveling some distance, we can take it. V equals to how much? G into T. Look here, another body we are taking. We are throwing upwards. We are throwing upwards. With how much velocity? U. After t seconds, this is the v1 and this is the v2. v2 equals to u minus gt. Find the relative velocity, means both are having the opposite direction, means we can do v1 plus v2. gt plus u minus gt. See, relative velocity is how much in this case? Only. The thing is, one is the freely falling body, another one is the vertically projected body. In that case, relative velocity is how much? U. Then our 9th question is, one raindrop is there. That raindrop diameter is 4 millimeters. When you know the diameter, we can able to find out the radius. That too I have converted millimeters to meters. While doing the simplifications, all units must follow the same system, either CGS system or MKS system or SI system and all this. So 2 into 10 power minus 3 meters is the radius of that raindrop. The question is, find the momentum of that raindrop. Momentum, what is the formula? Mass into velocity. You know that raindrop is having the spherical shape, that you should write it instead of mass into velocity, instead of mass, volume into density of water into under root 2gh. For freely falling body, how much velocity it will reach the ground? Under root 2gh. See, it is having the spherical shape, means 4/3 pi r cube into density into under root 2gh. So 4/3 instead of pi 3.14. This density r cube means 2 into 10 power minus 3 whole cube. Density of water they won't give. We should remember that 1000 kg per meter cube. So 10 to the power of 3 into under root 2 into 10 power 3. After simplification, this is the momentum of the raindrop. Like that we should find out the momentum of the raindrop. 10th SAQ, when the body is projected 45 degrees and we show that the ratio of maximum height to range is the 1/4 of this one. See, in this case we should remember that formulas. H maximum formula is u square sine square theta by 2g. But whenever they will mention maximum range, means theta equals to 45 degrees. So H maximum is how much? U square sine square 45 means 1 by 2 divided by 2g. It should be right u square by 4g. Like that, R maximum is how much? U square by g. When we can take it, H maximum equals to how much? We are writing 1 by 4 times of u square by g. But u square by g is nothing but R maximum. H maximum by R maximum value, we prove that here 1 by 4. But the thing is, we remember that whenever they will mention maximum range, means we can take it theta equals to 45 degrees. Then few more important problems we are discussing. One is the very important problems. The question is, if the body covers, if the person is starts, very important problem from motion in a straight line is, the given data is, first third of distance he is moving 10 kmph, second third of distance 20 kmph, then last third distance is the 60 kmph. In this case we can find out average speed is how much. Direct we can take this formula, V average equals to 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. So V average equals to 3 into v1 is the 10, v2 is the 20, then v3 is the 60, and here v1 v2 how much it is? 200, this is 1200, and this is 600. After simplification, V average equals to, this is 3 into 6 to 12, 10 into 1200 divided by, when you are adding this 1800 into 200, 1800 plus 200 is the 2000. These 3 zeros are cancelled. Here 2 6 here. Our answer is how much? 18 kmph. Many times they have repeated this problem. Very important problem is, one bullet is moving with 150 meters per second. It strikes the plank and it is traveling how much distance? 3 centimeters. Then it comes to rest. In this case, we should find out the acceleration and time. Look here. We can go through the v square minus u square equals to 2as formula. See, v is clearly 0. Velocity is how much? 150 into 150 equals to 2 into acceleration equals to 3.5 into 10 power minus 2 meters. Because centimeters we must convert into meters. After that you are getting minus 150 into 150 by 3.5 into 2 is the 7 into 10 power minus 2. So here you are getting that acceleration is approximately 3.2 into 10 to the power of 3.2 into 10 to the power of 5 meter per second square. Minus is representing deceleration, decreasing velocity, because initial velocity is 150, final velocity is 0. Then how to find out the time in second case? Time equals to change in velocity by acceleration. 0 minus initial velocity how much? 150 by minus 3.2 into 10 to the power of 5. After simplification we can get the time equals to 4.667 into 10 to the power of minus 4 seconds. So with the help of the first equation of motion and with the help of the third equation of motion we can find out the deceleration and time. Thank you everyone. Please subscribe my channel.